So next are properties of limits. I'll be honest with you, these properties are, they're really not hard. They're pretty basic and straightforward. It's the idea that when I have operations, it doesn't matter whether I do the operation then the limit or the limit then the operation. What it really is these limits allow us to do substitution. So the first is the limit of a constant. So the limit as x approaches a of a constant is the constant. And what that's really saying is if I had a function that is constant, like 4, the limit, it doesn't matter what x is approaching. So if x is approaching 7, my function's always at 4. It's not ever going to be anything else. So it has to approach the 4. Number 2 here is saying the limit as x approaches a of x is asking, as x is approaching a, what does x approach? Well, it has to approach a. And again, remember, these are not meant to be hard. Most people run into trouble with these properties by overthinking them. They really are very straightforward. It just doesn't feel like they should be. For these others, if I add or subtract functions inside a limit, I can break it up and add or subtract the limits of each function. Same with multiplying. I can multiply the functions then limit or limit of each function and then multiply. I'm not sure why that's still there. That was supposed to have been deleted. Same with division. I can do the division then the limit or the limit of the top divided by the limit of the bottom as long as the bottom isn't 0 because we're not allowed to divide by 0. This last one is actually the one that we will consciously do sometimes, and that's if I have a constant multiple, I will pull the constant out of the limit. So instead of saying the limit as x approaches a of c times f, I'll pull the c out and say c times the limit of f. Now, the way that AP exam likes to test these is they like to tell you, hey, we're not going to tell you what f and g are. We're just going to give you some of their limits. So like the limit as x approaches 4 of f is 1. The limit as x approaches 4 of g is 3. Find the limit as x approaches 4 of g of x plus 5. Well, what we would do is this is the limit as x approaches 4 of g of x plus the limit as x approaches 4 of 5. Well, we're told the limit as x approaches 4 of g of x is 3. The limit of a constant is always the constant, and this is 8. If I were to do a different example here, the limit as x approaches 4 of x times f of x would be the limit as x approaches 4 of x times the limit as x approaches 4 of f of x. Well, this is asking what does x approach while x is approaching 4? Well, it has to approach 4. And we're told the limit as x approaches 4 of f is 1, so that's 4 times 1, which is 4. Exponents seem weird, but you have to remember that exponents are really a form of multiplication. So g squared of x is really g of x times g of x. So I'm really doing the limit as x approaches 4 of g of x times the limit as x approaches 4 of g of x, which would be 3 times 3, which is 3 squared. So a lot of times people will skip all of this and just go straight to the 3 squared, which would be 9. And this one is kind of a combination of several. A lot of people do these in their head and they say, well, the limit as x approaches 4 of g of x is 3. The limit as x approaches 4 of f of x is 1, minus the limit as x approaches 4 of 2 is the constant 2. So this would be negative 3.